In this video, I'm going to talk about the indexing of NumPy arrays. We've already talked about indexing of Python sequences such as lists and tuples and strings, and for that we used integers and also slices. Well, NumPy is going to expand this to multi-dimensional arrays. It will also add two new techniques for indexing, and those are going to be lists of integers and also Boolean masks. So let's get to it. In the context of Python sequences, so lists, tuples, and strings, we learned that to index you must use square brackets, and inside those square brackets we put a selector which could either be a single integer or a slice. Well, now let's imagine that A is an n-dimensional array. Instead of a single selector, we're now going to have n selectors, one for each dimension. And we're still going to be able to use these two indexing methods, and we're going to call these the basic indexing methods. But we're going to add a couple more, and those are indexing with an integer list or array, and indexing with a Boolean list or array, aka a mask. And we're going to call these two advanced indexing. Let's refresh our memory on basic indexing. So we have here a one-dimensional array A that is of length 5, and it has 5 elements, the integers 0 through 4. So what is A0? Let's write down the indexes, 1, 0, 1, 2, 3, 4. They happen to be the same as the values. So the 0th entry is just a 0. How about the negative second entry? Okay, let's write down the negative indexes starting from the end. The negative second entry is a 3. How about indexing with a slice? Here we have a slice that is :1. So the start value is unspecified. So we will start at the beginning. And we go up to the 1th, but it's non-inclusive. So we end up here. And we end up with an array that is has a single element that's a 0. Now notice the difference between this example, the first, and the third example. In the first example, indexing with an integer gave us a value. And in the third, indexing with a slice gave us a subarray. All right, how about the fourth example? We have a slice ::2. So again, the start value is unspecified. The end value is unspecified, so we're going all the way to the end. And we have a skip value of 2. So we're going to grab the 0, skip the 1, grab the 2, skip the 3, grab the 4, and we end up with the array 0, 2, 4. Okay, let's move on to 2D arrays. Here we have a 2D array called M, and we're going to use now two selectors, one for the rows and one for the columns. What might this value be? M00. All right, let's write down the indexes for the rows and for the columns. And if I grab the 0th value, I get the 0 up here in the corner. How about this one? My row selector is a 1, so I'm looking at the row 1. And my column selector is a slice 2:. So I'm starting from the second, and I'm going all the way to the last column. And when I intersect these two, I get this subarray, 7, 8, 9. Okay, this last one has two slices as selectors. For the rows, we have 1:. So that is starting from the 1th row and going all the way to the end. And the column selector starts from the beginning and goes to the 3rd, non-inclusive. So we have this. When we intersect those two, we get this submatrix, 5, 6, 7, 10, 11, 12. Now we're going to see how we can assign values or write values to a NumPy array. We're going to use the same example of the cell phone tower and the cell phones. And you'll recall that we had 200 cell phones and we had their X, Y, and Z positions. So, by the way, this notation that I'm getting from JupyterLab is scientific notation. So, e plus 0.2 means multiply times 10 to the 2, or multiply times 100. And so this is 146.63, and this is 15.57. Okay, let's say I wanted to update the position of the cell phone in row 1. I'll do that first by selecting that cell phone and then assigning it a value. Here I've selected the cell phone, and by the way, this notation, the colon, is a slice where I've omitted the start value and the stop value, and so it just simply means select all columns. If I wanted to select all rows of column 1, I'd do something like that. Okay, so, well, let's start just by changing the x value of this position. In that case, I will select the 0th column and give it a new value. Let's say 10. Let's see what that has done. You see now the x value of the 1th cell phone has been changed to 10. If I want to update the entire position, x, y, and z, then I'm going to select all 3 columns, and I have to give it an appropriately sized list or array. So I'm going to give it 10, 11, 12, the 3 entries for the x, y, and z. And in this case, I'm giving it a list, but I could also give it an array, and that would work just as well. So let's do it with a list. Now I see that the position has been changed to 10, 11, and 12. What if I wanted to change the positions of phones 1 and 2? In that case, I would select those 2 rows with a slice 1 through 3, non-inclusive, and I'd pass in the appropriately sized array. In this case, it should have 2 rows. So maybe something like that. And again, this could be a NumPy array. I'm using a list of lists. When I run that, I see that the positions of 1 and 2 have been updated. Okay, very good. What if I wanted to update the position of cell phones 1 through 50? Then I would do the selection. And on the right-hand side now, I don't want to copy 10, 11, 12, 50 times. But NumPy will apply broadcasting rules if I pass in something like that. So it will copy 10, 11, 12, 50 times. We can see here that all of the positions have been changed from 1 through 50 have been changed to 10, 11, 12. Okay, I can also pass in a scalar here, say 100, and that scalar is going to be copied to all of the positions. So if I run that, I see that the X, Y, and Z position of all cell phones 1 through 50 has been changed to 100. We've now covered basic indexing, so we're going to move on to advanced indexing. And remember, there are 2 types. There is indexing with an integer list and also Boolean masks. So let's start with the integer lists. Sometimes you want to make a selection that is not evenly spaced, and so slices don't work. For example, if I wanted to select this 3 and this 1 and this 7, I could not do that with a slice. So how could I do it? Well, let's write down my A and my brackets, and in here I'm going to put a selector that's going to be a list. So it's going to be a list like that. It could also be a NumPy array. What do I put in that list? Well, let's write down the indexes here, 0, 1, 2, 3, 4, and 5. I put the indexes of the desired items. So that would be 1, 2, and 5. That will give me the desired result. Okay, how does it work with 2D arrays or matrices? Well, let's say that I wanted to select this item, and this item. What are the indexes of these? Well, this is the 0 first item, this is the 0 fourth item, and this one is the 2 third item. Okay, so to select that, I would say A, here's my selector. I'm going to need a row selector and a column selector. Each of those are going to be lists or NumPy arrays. And in here, for the rows, I'm going to put in the row indexes of the 3 items I need. So 0, 0, and 2. 0, 0, and 2. And for the column selector, I will use the respective columns, 1, 4, and 3. 1, 4, and 3. So that is indexing with a list of integers or arrays. Our next type of advanced indexing is something that, again, you cannot do with a regular Python sequence, but that you can do with a NumPy array. And it's super useful. It's called Boolean masking. So here's how it works. Say you have a NumPy array A. In this case, it's one-dimensional, but this works for higher dimensions. We'll see that in a bit. And a mask is then a list or an array of with the same number of elements as the dimension that you wish to index. So in this case, this is a one-dimensional array with 6 elements, and so is the mask. So if I now index the array using the mask, so I literally pass the mask in as the selector for the array, then this is going to produce an array where, for example, this 12 gets through the filter because there's a true there, and so I have a 12. The 3 gets blocked by the false, so it doesn't come through. The 1 comes through, so I get a 1 here. The 4 comes through. This 4 gets blocked, and this 7 comes through. So this is the result. I get a 1D array with a 12, a 1, a 4, and a 7. So let's go to the code to continue. We're going to use our cell phone towers example again, and remember that we had used this formula to compute the distance from the tower to each of the phones. And we wanted to find the position of the closest phone, and so we used np.argmin, passed in D, and this told us that the 74th phone was the closest. Now, we could have also used the version of argmin that is attached to the NumPy array. That would have given us the same thing. And now we can take this index and pass it as the row selector into position phones and get all of the columns. That will give us the exact position of the closest phone. Okay, now next challenge. We need to find the positions of phones that are within 200 meters of the tower. And this is where Boolean masks are going to be very useful. What we want to do is create a mask that is pointing out all of the phones that are closer than 200 meters. That mask we can create with a comparison operator, the less than sign. So if I say d less than 200, that is going to apply that operation, less than 200, element-wise to all of the entries in the D array. And so it will create a mask where it's true for wherever D is less than 200. So we can use this as a mask. We don't even have to create a separate variable. We can just pass it into phones as the row selector, and again select all of the columns, and we find that there are 3 phones that are within 200 meters, and these are their positions. Very good. Now let's say that we want to find the positions of phones that are between 200 and 300 meters of the tower. In this case, we would like to create a composite mask, or one that has 2 conditions in it. One is that D is greater than 200, and the other is that D is less than 300. So each of these are going to be a mask, an array of 200 Booleans. And the question is, how do we combine these element-wise to create a single mask with the 2 conditions? For this, we can use NumPy's element-wise Boolean operations for NumPy arrays. And these are the following. So the Python operations are called and, or not. And the respective NumPy methods are logical and, logical or, and logical not. But you can also use these shorthand symbols, which are the ampersand, this vertical bar, and the tilde. So let's try that. What if I tried to combine these two with an and? I need the distance to be between greater than 200 and less than 300. So this would seem like the appropriate thing to do. When I run this, unfortunately, I get an error because the order of operations isn't just right. So it's doing 200 and D before evaluating the D greater than 200 and the D less than 300. So I need to use parentheses here in order to get the order of operations right. And that is always the case when you use these shorthand Boolean operators. So that works. And now I can pass this in to my phones array as the row selector. And it gives me that there are 1, 2, 3, 4, 5, 6, 7, 8 phones that are between 200 and 300 meters of the tower. Now I could also use the np.logical function, np.logical and now I pass in my two masks. One is d greater than 200, and the other is d less than 300, and these are two arguments into this method. And from here, let's call this a mask. I get a mask, and I can pass this mask as my row selector into the phones array, and I get the exact same thing. So Boolean masks are very, very useful because they allow us to select items from a NumPy array based on some condition that can be any condition as complicated as you want to make it using and, or, and not.